welcome back. And let's see some more things here. So till now we have seen what you mean by continuous time signal, what you mean by discrete time signal, and we have seen what is an analog signal, what is a digital signal. Okay, so analog, digital, these things are not much important for us. Let's go with a continuous time and discrete time signals again. So once we complete this, the next thing what we have to see is basic continuous time signals. Okay, so let's see basic continuous time signals. Give a heading, basic continuous time signals. In that, the first one what we have to see is unit impulse function. It is usually denoted with a delta t, delta of t. So have you ever heard the word impulse? In plus 12th you might heard this word impulse force. That means the force with a large amplitude applied for a small duration. Amplitude has to be very large, but the duration of the application of the force must be very small. Then we can call that is impulse force. So in the similar manner we can define impulse function. So before going to define this impulse function, let me tell you something. Usually the continuous time signals can be represented mathematically and graphically. We can define the signals mathematically and graphical way. So let's see, the first we will see mathematical way how we can define impulse function. Impulse function delta t is equal to, maybe its value is infinity, maybe its value is 0. Infinity if t is equal to 0, and else, that means if t is not equal to 0, its value is 0. That means first it is existing only at t equal to 0, means at t equal to 0 its amplitude is infinity, and the remaining values of time its value is equal to 0. Can I say it is a continuous time signal? Of course it is a continuous time signal. Why, sir? Because it is defined for every value of time. At each and every instant we can say the value. If suppose I am asking impulse function at t is equal to 2, which is not 0. So if it is not 0, we can say its value is equal to 0. If I say t is equal to 2.5, still value is equal to 0. At each and every instant its value is equal to 0, except at t equal to 0. But infinity is already, which is not a good quantity we have to discuss with. That means it is not analytically possible. That means we cannot say anything about infinity. Infinity means infinity, which is a undefined value. So there is another way to express this, which is nothing but integral minus infinity to infinity delta t dt is equal to 1, which is nothing but area under impulse function is equal to 1, which is area. This definition is very, very important. Area under impulse function is 1. This is what the mathematical definition of impulse function. Then graphically, how we can show this impulse function with respect to t? It is existing only at 0. It is existing only at 0. Its value is infinity. I don't have the board so that I can go to infinity. Then how we can show this, sir? So we can show it like a spike. We can show it like a spike. This is the way we can show it, and we can write 1 here. See, what this spike indicates, its amplitude will go to infinity. But what is this 1 indicates? It is nothing but area of the impulse function. So this is the way we can define or we can represent impulse function graphically. Okay, this is the way we can define. Okay, so this is about the impulse function. Just take a note. Here we have to understand one thing. If I ask impulse function, is it defined for all the values of time? Of course, its value is known for all the values of time, so that we can say it is defined for all the values of time. Next, where it exists. So do you see the difference between the words existing and defined? Defined means we have to know each and every value. Next, existing is where it is going to be non-zero. So where it is going to be non-zero, at t is equal to 0, we are having the impulse function. Then we can say it is existing at t is equal to 0. That's okay, sir. Suppose if I ask like this, delta m. So delta of m, where it exists, obviously whenever t is equal to 0, there it is existing means the argument value, argument means inside the bracket, whenever the argument value is 0, there we are getting a impulse function, there we are getting an impulse function. So here also, where we are getting an impulse function, here at m is equal to 0, we are going to get an impulse function. At m is equal to 0, we are getting an impulse function. Suppose if I ask delta t minus 3, where this impulse function exists. So whenever the argument is 0, then we are going to get an impulse function. What is the argument here? Or inside bracket, that is t minus 3 is equal to 0. Argument is nothing but t minus 3 has to be 0. That means it is existing at t is equal to 3. So if I want to draw this delta t minus 3, so it looks like this. At 0 it is not existing. In this time it is existing at 3. Impulse function with the area 1. So this is nothing but delta t minus 3. So if I ask draw delta t plus 2, where it exists, again the same thing, whenever the argument is 0, there the impulse function exists. Here the argument is nothing but t plus 3. When this t plus 3 is equal to 0, t will become minus 2. So the impulse function exists not at 0, but it is at minus 2, whose area is equal to 1. That is what the delta t plus 2. Okay, make a note. So somewhere you can write impulse function exists at argument is equal to 0. When argument is equal to 0, impulse function exists when argument is equal to 0. Argument means inside the bracket value. Make a note. If suppose somebody is asking, let's take a question example, delta t square plus 5t plus 6 is equal to, simply they have given like this, options are given like this, which is delta t, option B, delta t plus 2 plus delta t plus 3, option C, delta t plus 6, option D, delta t plus 2 multiplied with delta t plus 3. So these are the options they have given. Try to understand. So how we can solve this question? First, try to understand. I just now told you impulse function exists whenever the argument is 0. So again I am asking, what is the argument here? What is the argument? T square plus 5t plus 6 is equal to 0. That means if I solve this equation, you are going to get t value is equal to, let's say, -2, -3, or yeah, t plus 2, t plus 3. Yeah, t is equal to -2, -3. So at these t values, we are going to get an impulse function. That means if I draw this function with respect to t, let's call it is 0, let's call it is -2, let's call it is -3. At this place, we are getting an impulse function 1. At this place, another impulse function. So these are the two impulse functions we got. So at -2, we are having an impulse function which is delta t plus 2. At -3, we are having an impulse function delta t plus 3. So this is nothing but delta t plus 2, and this is nothing but delta t plus 3. Two impulse functions, so we have to add them so that we can get, so one impulse function added with another impulse function, then we can get this kind of two impulse functions, which is option B, okay, make a note. So just remember, wherever impulse function exists, that means wherever the argument is 0, there the impulse function exists. Suppose if I ask you to draw this delta sine t. If I ask you to draw this function delta sine t, how you can draw this? Again the same thing, impulse function exists whenever the argument is 0. So here the argument is nothing but sine t. First check the sine t curve. Where the sine t curve is 0, there we will see we can get an impulse function. So if I say (0, pi, 2 pi and so on, minus pi, minus 2 pi. So this is what the sine t curve. So whenever the argument is 0, there we are going to get impulse function. The argument, which is nothing but sine t, is becoming 0 at 0, pi, 2 pi and so on, minus pi, minus 2 pi and so on in the negative side also. So if I draw this function delta sine t, (0, pi, 2 pi and so on, minus pi, minus 2 pi, like that. So if I say at these places sine t becomes 0, then delta sine t exists at those places. We are going to get one impulse function at 0, another impulse function at pi, 2 pi and so on, minus pi, minus 2 pi and so on. So this is what the delta sine t curve, how it look like. Okay, so wherever 0, there we are going to get an impulse function. Okay. Make a note. Next, very important thing to understand about the impulse function is strength of the impulse function. Strength. Strength is nothing but the coefficient of the impulse function. Suppose if I say delta t, what is the coefficient here? 1 multiplied with delta t. What is this 1 indicates? That is nothing but strength. that coefficient, strength, or sometimes we can call it as coefficient, which is equal to 1. What this usually indicates is nothing but the area under impulse function, which is nothing but area. Suppose if I ask k delta t, k delta t. So here, what is this k indicates? It is nothing but the strength or coefficient, which is nothing but the area under the impulse function, which is nothing but k. So here, k indicates strength, that is nothing but coefficient, which is nothing but k, that is area. So remember, so many people are getting confused with what is a k, that is coefficient, that is nothing but, so many people will say amplitude simply, but that is not the amplitude in this case, that is nothing but area under the impulse function. So for impulse function always the amplitude is infinity, no doubt in it, but infinity is not a calculate, means we cannot calculate or we cannot summarize anything from the infinity. That's why we always consider area under the impulse function is more important quantity than the amplitude. Amplitude is always infinity, there is no doubt in it, but only thing we always taken care is nothing but area. So keep that in mind. Whenever if a impulse function is given, the area is the important quantity here, not the amplitude. Okay, take it. Properties. Let's see one by one. I'm not giving any name. Name is not much important. So let's say area under impulse function. We know that minus infinity to infinity delta t dt. Everybody knows its value is equal to 1. Area under impulse function is equal to 1. If I ask integral minus infinity to infinity delta t minus t naught dt. See here, delta t minus t naught is nothing but an impulse function, but instead of existing at t is equal to 0, it is existing at t naught. Just the location of the impulse function got changed, but still what is the area under the impulse function is 1. Suppose if I ask integral t1 to t2, so not infinite limits I have taken only particular limits, which are nothing but t1 and t2 delta t minus t naught dt. What is the answer you are expecting? What is the answer you are expecting in this case? So many people will say 1, but my answer is it may be 1, it may be 0. We cannot be sure. Based on what we can say its value is equal to 1, its value is equal to 0. Try to understand. Suppose, so let's say there is an impulse function at t naught. If I consider the limits t1 and t2 in this manner, t1 is here, t2 is here. So if I integrate this function within the limits t1 and t2, then I can get the value is equal to 1, no doubt in it. What if I take another case? There is an impulse function at t naught, but I have taken the limits which are like this, t1 here, t2 here. If you observe carefully, if I take the integration of this function within the limits t1 and t2, I can get 0 only, because between t1 and t2, first of all, that signal does not exist. In these limits, the delta function does not exist. So that if you try to find out area between t1 and t2, we can get the value is equal to 0. So I can say we can get value 1 when t0 lies between t1 and t2. Can I write like this? This value is equal to 1 if t1 less than t0 less than t2. Otherwise, else its value is equal to 0. This is what we have to say. So if the impulse function exists within the limits, then we can get the 1. If the impulse function does not exist within the limits, then we can get 0. I hope you understood. Okay. another property, which is a time scaling property. Time scaling property. What is this property? Suppose if delta AT is given. Delta AT is given. So first of all, where this impulse function exists, again argument has to be 0. Delta AT is equal to 0. That means t is equal to 0. That means it is also existing at t is equal to 0 only. There is no doubt. But only thing is, I just now told you, impulse function is, the amplitude is not the important quantity, the area is the only important quantity. So we can rewrite this as 1 by mod A delta t. That means this function is having area 1 by mod A. How, sir? So that you can understand. Let's say a proof. Suppose if I take delta, let's say 2t. In place of A, I have taken 2. So this function is also existing at t is equal to 0 only, but I am trying to find out area. Let's say area. Area is nothing but the coefficient. Area is equal to integral minus infinity to infinity delta 2t dt. This is what the area definition is. Area means integration. Let's say, let 2t is equal to some m. Then what is dt? dm by 2. Suppose if t is equal to minus infinity, that implies what is the m is equal to t value minus infinity, then m is also equal to minus infinity. If t is equal to plus infinity, then m value is also plus infinity. So I can rewrite this integral as integral minus infinity to infinity delta m dm by 2. So here if I take 1 by 2 common out, this is becomes 1 by 2 is the area, because delta m dm, the area under the impulse function is always 1, but we are having a factor 1 by 2, so I can say 1 by 2. So this is also an impulse function, but its area is equal to 1 by 2. So I can rewrite this as 1 by 2 delta t. 1 by 2 delta t. Sir, then why we have written modulus? You can understand. Another example. If I take another example, which is delta minus 2t minus 2t. Again, if I ask a value is equal to minus 2, where this signal exists, argument, that is minus 2t has to be 0. That means t is equal to 0 only. But only we are concentrating on the area now. Let's see, area is equal to integral minus infinity to infinity delta minus 2t dt. Delta minus 2t dt. This is what the area definition. Again, if I take if let minus 2t is equal to m, then what is dt? Minus 1 by 2 dm. If t is equal to minus infinity, that is the lower limit, then m value, because already we are having a minus sign here, that will become plus infinity. T is equal to plus infinity, then m is equal to minus infinity. This is what it is going to be. Then we can write this as, if I take dt is equal to minus 1 by 2 dm, then if I write minus 1 by 2 out of the integral infinity to minus infinity delta m dm. If I take these integrals which are not in the proper form, so if we make them in proper form, that means change of the integrals, that is limits of the integral interchanging, then minus sign again will come. 1 by 2 integral infinity to minus infinity to infinity delta m dm. So this value is equal to 1, finally 1 by 2. So this delta minus 2t is also having area is equal to 1 by 2. So this is also can be written as 1 by 2 delta t. That's why I can simply say this is nothing but modulus of minus 2, which is nothing but 2. So if it is plus or minus, doesn't matter, we always consider that is nothing but 1 by mod a. Okay, just make a note. If they have given delta at plus b, what is this is going to be? So obviously, let's say first one more point. Where this impulse function exists, argument has to be 0, at plus b is equal to 0, t is equal to minus b by a. So it is existing at t is equal to minus b by a. So impulse function existing at t is equal to minus b by a can be written as t plus b by a. Okay, no problem. So this is also impulse function which is existing at t plus minus b by a. But only thing is, what is the area under this impulse function? That is 1 by mod a. So you have to write like this. So whenever if it is delta at by b is given, that is nothing but if you take a common out, 1 by mod a delta t plus b by. Very, very important. And one more thing, so time reversal property. Time reversal property. Time reversal property. That means if I take delta minus t, so I simply replaced a with minus 1. If a is replaced with minus 1, I can get delta minus t. Then what you are expecting? The same thing. 1 by mod minus 1 is nothing but 1. Finally, delta t. If you are a beginner, you may not know this. If you are, let's say, if you know some of the things, we can say any signal satisfies this condition. If t is replaced with minus t, still I can get the same thing. I can call that signal is a even function. Even function. It's a even. We will elaborately discussing this even function and odd function later. But for the time being, any function, suppose if you take x of minus t, if you get x of t, that is a even function. If you take x of minus t, if you get minus x of t, that is a odd function. This is actually even function, odd function definitions. So from the definition of even function, if you take delta minus t is equal to delta t, then I can get even function. Make a note. One more property, that is product property. Before understanding this product property, let's say if two signals are there, if you multiply them, what do you mean by multiplication of two signals then? That means one signal, another signal is there. If I multiply them, what will happen? That means at each and every instant of time, what is the amplitude of the signal? What is the amplitude of the signal? We have to multiply them. In the same manner, addition. That means what is amplitude? What is amplitude? Add them. Subtraction means amplitude minus amplitude at each and every instant of time. This is what the amplitude operations. We will see that later. But time being, so addition means addition of amplitudes. Multiplication means multiplication of amplitudes. Subtraction means subtraction of the amplitudes. These are the things. So product property means, let's say, if any signal x of t multiplied with delta t minus t naught. So if you observe carefully, if I take arbitrarily a signal x of t, which is like this, let's say x of t. If I take delta t minus t naught, delta t minus t naught, which is not existing at 0, which is existing at t naught. which is existing at t naught, whose amplitude is infinity but its area is equal to 1. Okay, now try to understand. If I multiply these two signals, at each and every instant of time the impulse function is 0 except at t naught. At t naught its amplitude is infinity and its area is equal to 1. If I multiply this signal with x of t, then everywhere if I multiply the amplitudes, they are going to be 0. 0 multiplied with something has to be 0. But at t naught, if I take the amplitude is infinity, so at t naught, what is the amplitude of x of t signal? At t naught, amplitude of x of t signal is x of t naught, which is some constant value, let's say 5, 6 or something like that. I'm just assuming at t naught, let's say we are having some constant amplitude, the value of x of t naught may be 5, 6 like that. If it is multiplied with this one 5 delta t minus t naught, then what will happen? That 5 itself is nothing but the area or strength of the impulse function. That means at t naught, x of t naught multiplied with infinity is going to be infinity, means that means we are having impulse function at t naught. But what if I ask what is the area of that impulse function? That is nothing but x of t naught. So this is equal to x of t naught delta t minus t naught. Remember, in the product property, if any signal is multiplied with delta t minus t naught, then t has to be replaced with t naught. This is the one way to say. Very important. Another way, suppose if I multiply x of t with delta t, that means any signal is multiplied with delta t. Because impulse function is existing only at t is equal to 0, then we have to replace t with 0. That means x of 0 delta t. This is what the product property. Okay, make a note. Next, shifting property. Shifting property. What is the shifting property? Let's try to understand. Integral minus infinity to infinity any signal, arbitrary signal x of t multiplied with delta t minus t naught dt. Now try to understand. From the product property, any signal multiplied with delta t minus t naught, then t has to be replaced with t naught. That is nothing but x of t naught. So which is nothing but a constant quantity. If I take it from the integration, this is x of t naught integral minus infinity to infinity delta t minus t naught. Area under impulse function is equal to 1. Finally, we are going to get x of t naught. X of t naught. See, I can modify this result like this. T1 to T2 x of t delta t minus t naught dt. What will happen now? This value may be x of t naught. This value may be 0. When this value is x of t naught, if impulse function lies between t1 and t naught, that means t1 less than t naught less than t2. Else its value is equal to 0. Else its value is equal to 0. So whenever if you see the integrations, just observe the limits so that you can understand its value may be 0 or x of t naught. Okay. Summary. First one, very important one. Delta AT is equal to 1 by mod A delta T. I am not writing any property name here. I am just giving you this. Suppose if it is delta AT plus B, which is 1 by mod A delta T plus B by A. T plus B by A. Delta minus T which is delta t. That is a even function. Next, x of t into delta t minus t naught. Then we have to replace t with t naught. X of t naught delta t minus t naught. Suppose if integral minus infinity to infinity x of t, or in general if I write t1 to t2 x of t delta t minus t naught. Its value may be x of t naught or its value may be 0. X of t naught if t1 less than t naught less than t2, else otherwise its value is equal to 0. Just make a note of the question from the workbook. Question number 1. If I ask integral minus 1 to 3 sin t into delta t minus pi by 3 dt is equal to how much? Or 6. Its value is equal to 0. Why? Because impulse function exists at 6, but whereas the limits are only from minus 1 to 3. I hope you understood. So this is what the one question. Let's say another question, question number 2. Sin t delta t minus pi by 3. What is going to be? It's a product property. Let's call it as a function sin t, which is x of t. Any function multiplied with delta t minus pi by 3, then t has to be replaced with t naught, which is nothing but pi by 3 in this case. So here we are going to get sin pi by 3 into delta t minus pi by 3. That is nothing but root 3 by 2 delta t minus pi by 3.